In section 1.5, we're going to focus on solving two-step equations. So we're still working on our learning goal of solving linear equations, and we're kicking it up just a teeny tiny little bit, and we're adding an extra step. Okay, so when we were evaluating expressions and using order of operations, we talked a lot about PEMDAS, right? To help us remember the order in which to perform those operations. We do what's in the parentheses first, then we do our exponents, then we do multiplication and division from left to right, then we do addition and subtraction from left to right. But this is a really important part here, and I might even want you to underline it in red. We use that when we're simplifying an expression. What's the difference between an expression and an equation again? Well, equations have equal signs, expressions don't. So this is a real big difference between when to use PEMDAS and when to use what I like to call SADMEP. Of course, you may have realized that SADMEP is PEMDAS in reverse, right? So PEMDAS helps us remember what to do in simplifying an expression. SADMEP helps us remember which order to undo operations when we're solving an equation. So the big difference between when to use PEMDAS and when to use SADMEP is whether you're evaluating an expression or whether you're solving an equation. That might be a really good question for you to think about putting in the left-hand column here. Okay, so SADMEP means we undo addition and subtraction first. Then we're going to undo multiplication and division. Then we might undo exponents. And then last, we're going to undo anything that might be inside parentheses or grouping symbols, right? All right, so let's look at a couple of examples. Here I have I have one expression and I have one equation. Here on the left, I have the expression 2x plus 1. Here on the right, I have the equation 2x plus 1 equals 7. So if I'm solving an equation, I'm going to use SADMEP. If I'm evaluating an expression, I'm going to use PEMDAS. Okay, so now let's do each one of these. So if I have the expression 2x plus 1, and I want to evaluate that when x equals 3, you know that that means plug in 3 for x. This becomes 2 times 3 plus 1. Now we don't have any parentheses, don't have any exponents. Ooh, we do have multiplication, so I'm going to do that first, of course. 2 times 3 is 6. We don't have any division. Oh, we've got addition, that comes last. 6 plus 1 is 7. There was no subtraction, so we're done. However, when solving the equation, I'm going to do this in a little bit different order. Remember when I was evaluating, the first thing I did was multiply. And the second thing I did was add. But when I'm solving this equation, the first thing that I want to undo is the addition or subtraction. So first, I will subtract 1 from both sides of the equation. So now I'll have 2x is equal to 7 minus 1, which is 6. Then I'm going to undo any division or multiplication that I see. Well, there's no division, but there is multiplication. So I'm going to undo the multiplication by dividing. We'll divide both sides by 2. 2 divided by 2 is 1. So we have 1x, or just x. And 6 divided by 2 is 3. Now we can always plug that back in and check it, but oh wait, I already did that over here, right? X is 3, 2 times 3 is 6, 6 plus 1 is 7. That's a check. Alright, so now you kind of see how to use SADMEP to help you know what operation to undo first when solving an equation. But let's look at a few more examples. Alright, so let's solve this for x. We have 5x plus 1 equals 16. So SA, DM, EP. Do we have addition or subtraction? We do, we have addition, so I'm going to undo that first. So I undo addition with subtraction, so we'll subtract 1 from both sides of the equation. That leaves me with the 5x term. 1 minus 1 is 0. 16 minus 1 is 15. So I took care of subtraction and addition. Now let's look at multiplication and division. Again, we have multiplication, so I'm going to undo that with division. So we'll divide both sides by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So we get x equals 3. Now we'll do a quick check. Go back to my equation. 5x plus 1 equals 16. Plug it in to make sure it works. 5 times 3 plus 1. 5 times 3 is 15. 15 plus 1 equals 16. Yep. Totally good to go. We solved the equation correctly. Alright, so now let's do one that's just a little bit different, and I threw some negatives in there too. So SADMAP, always a good idea to write it out every single time. Helps you keep track of what you've checked. Do we have subtraction or addition? We do. We have subtraction. So we'll undo that by adding 4 to both sides of the equation. So bring down the 3x, because there's no like terms for any other x terms. Negative 4 plus 4 is 0. Alright, and then negative 13 plus 4, that's a negative and a positive, so we subtract those numbers and keep the sign of the bigger number, so that's negative 9. So we undid the addition and subtraction. Well, there was only subtraction. Now we don't have any division, but we do have multiplication, so we'll undo this multiplication by dividing both sides of the equation by 3. 3 divided by 3 is 1. Negative 9 divided by 3 is negative 3. So we took care of that, and we've solved, so there's no exponents or parentheses that we even need to take care of. Yay! Okay, so, and then, quick check, plugging it back in. 3 times negative 3 minus 4, does that equal negative 13? 3 times negative 3 is negative 9. Negative 9 minus 4 is negative 13. Negative 13 equals negative 13. Hooray! We did it right. Okay, so now I want to talk about equations with division. The last two examples had multiplication in them. They may have had addition or subtraction, but every single one of the last two examples had multiplication. So there's some different types of problems that might have division. So you have to consider whether or not you have a fraction bar, which is really a grouping symbol, and that changes what you're going to undo last, or not. Okay, so if we have this example, solve for x plus 1 over 2 equals negative 5. If we just look at the x plus 1 over 2, this little fraction bar guy right here, you know the one right here, this guy, it's really a grouping symbol. It's implied that this numerator, x plus 1, is in parentheses. That means I'm not going to undo the addition first. So if we think about our SADMAP, SA, DM, EP, it's almost as if we don't even know what's in the numerator, right? There's just something up there. We don't know what it is. It could be anything. All we know is it's inside of parentheses. It's inside of a group. That means the numerator is the P part of SADMAP. That gets undone last. So we don't really have addition and subtraction to undo first. What we really want to undo is the multiplication or division, and in this case it's division. So what I would do in this equation, and I'm going to leave that crossed off for now because it doesn't matter what's up there. I'm going to undo it by multiplying both sides by 2. Right? Think about that as 2 over 1 if you like. 2 divided by 2 is 1. And so all we have left is that crazy numerator. And then over here that's going to equal negative 5 times 2, which is negative 10. Okay, well now it's not so helpful to have that all scribbled out. Let's go back and erase that and realize that, okay, my numerator was really x plus 1. Now we have addition. That's the only thing that's left. So now we're going to undo that addition with subtraction. So, subtracting 1 from both sides leaves x on the left. Negative 10 minus 1 is negative 11. And we're done. We want to plug it back into check. Negative 11 plus 1 over 2. We want to know, does that equal negative 5? Negative 11 plus 1 is negative 10. Negative 10 over 2 is negative 5. Negative 5 equals negative 5. Check. We're good. Now, just a word of caution here, guys. Don't leave stuff scribbled out in your notes like this. If you want to, do some kind of note, you might say something like this. This could be anything or something like that. It doesn't matter what's in the numerator. What matters is we undo the division first. Okay? Now that's when we had a fraction bar. Alright, so what if we still have a fraction bar, but look, we don't have a group that's in the fraction bar. So there's nothing in that numerator that has to get undone last. In this case, if we look at SADMAP, SADMAP, there we go, try that again. The plus 5, that's not part of the fraction bar. So that's addition that I can undo first. I'm just adding 5, the constant, all by itself. It's not involved in the fraction at all. So this is an example where we start by undoing the addition first. So that leaves me with x over 2, 5 minus 5 is 0, equals 3 minus 5 is negative 2. So we've undone the addition and subtraction. Now we can undo the division. We're dividing by 2 here, so to undo that, we multiply both sides by 2. Alright, think about that as 2 over 1. 2 divided by 2 is 1, so that leaves me with x on the left. Negative 2 times 2 is negative 4. So that's my solution. And again, we're going to check it. Negative 4 over 2 plus 5, we want to know, does that equal 3? Negative 4 divided by 2 is negative 2. Negative 2 plus 5 is 3. 3 equals 3. We did it right. Alright, so two different types of problems that we have with a fraction bar. Watch out for these. One of them is going to look like this, where you have a whole expression in your numerator, I don't know, equals 10, something like that. The other one might look like this, where it's just your variable divided by a number, and then you're adding or subtracting your constant all on its own. So notice the differences between these two types of equations. Here, we undo the division first. Here, we undo the subtraction first. So pay very close attention to those two differences. Alright, so now I want to show you one other example. This equation looks complicated, but it can actually be solved in 2 steps. Again, notice that there are parentheses in my problem. There's 2 different ways we could go about solving this. The first way is to think about what's in those parentheses, forget about it for right now, and think that we're going to undo that last. That means that this problem is now 4, and parentheses here means times, 4 times x minus 7 equals negative 16. So the first thing that we're going to undo is that multiplication, because the subtraction is in the parentheses, it gets done last. So first we're going to undo the multiplication. We do that by dividing both sides by 4. And the only reason I can do that is because x minus 7 is in those parentheses. Okay? So 4 divided by 4 is of course 1. So that leaves me with x minus 7 over here. You could write it in parentheses, but even if you do, the parentheses aren't doing anything for you, so why bother? So let's just leave it as x minus 7. And then over here, negative 16 divided by 4 is negative 4. Now, we're going to undo what was in those parentheses, the x minus 7, which is subtraction. And so we'll undo that by adding 7 to both sides. So negative 7 plus 7 is 0. Negative 4 plus 7 is 3. And we can quickly check this by plugging in 3 into the original equation. So it would be 4 times 3 minus 7 equals negative 16. So do what's in the parentheses first. 3 minus 7 is negative 4. And 4 times negative 4 is, of course, negative 16. Negative 16 equals negative 16. Totally good to go. Now I told you there were two ways to solve this equation. One way was to divide both sides of the equation by 4 first. Save what's in the parentheses and undo that last. The other option, maybe what you were thinking of when you initially looked at this problem, and that's to simplify the equation by distributing first. So if I want to do that, let's start with the equation. We have 4 times x minus 7 equals negative 16. We distribute, multiply 4 times each term, so we have 4x. 4 times negative 7 is negative 28 equals negative 16. So now my operations are multiplication and subtraction. In SADMAP, I undo the subtraction first, so we'd add 28 to both sides. There we go. And when I add 28 to both sides, now we have 4x is going to be equal to, let's see, I think that'll be 12. Now we still have multiplication here, so we're going to undo that multiplication by dividing. So divide both sides by 4. 4 divided by 4 is 1, so we have 1x. 12 divided by 4 is 3. Oh, good, that's the same answer that we got before, and we already checked that, so we know it's correct. Now, just notice, when we did it the first way, when we treated what was in the parentheses as a group and we undid that last, we had only 2 steps. We divided by 4, and then we added 7. However, when we distributed, we had 3 steps. The first step was to distribute the 4. The second step was to add 28 to both sides. And the third step was to divide both sides by 4. Now, it doesn't matter which way you work it. Both of these are going to lead to the correct solution. So do whichever way you like better. When you're distributing, that gives you more chances, more opportunities to make mistakes. So I don't think it's the best way. Another argument for undoing the multiplication first and leaving that in a group is if this little number right here is a fraction, you almost always want to get rid of that fraction first instead of multiplying that fraction through and making more fractions everywhere. So we'll look at some examples of when this number here is a fraction. We'll look at some examples in class and talk about the different ways we could solve the equation and which one might be better given the situation. Okay? So, that's it for this. Go through your summaries. Your summaries should definitely talk about the difference between PEMDAS and SADMAP and when to use each, and maybe a couple of examples of what operations you need to undo when solving a two-step equation.